Before I add and subtract, or multiply and divide, it's the order of operations. Can I keep this live? I'm the denominator dominator.
Okay, at the request of a couple students and some people up in the Math Center as well, I thought that I would cover a problem on the homework section 8.2, the application section, specifically the batting average problem. I'm not going to do the exact problem. Instead, I'm going to go ahead and do a subtle difference on it, but it's essentially the same problem. So suppose you go to a casino to play the slot machines. So you're there gambling, right? And you're going to play every single minute that you're there. But you're only going to be there 18 hours. The first 6 hours, your average hourly winnings are $52. $52 an hour is what your average is. What must your average be for the remaining time to get a total average of $75 per hour for winnings? Okay, so this is if you replace the word casino and slot machines with baseball and batting averages, and replace the numbers, it is the same problem as the batting average problem. So let's set this up here. Let's see. I know that we're going to be there. Well, first of all, let's talk averages. The average of numbers is the sum of numbers, right, over the total total amount, I guess you could say. Okay. So in our case, I know that the total number of hours I'm going to be there is 18, right? Now the trick here is to read into this problem. The first 6 hours, each hour on average for the first 6 hours, I won $52, right? That means the very first hour on average I won 52. The second hour on average I earned 52. On the third hour, same thing. Fourth hour, same thing. Fifth hour, and sixth hour. Now, I'll have people say, but wait a second, you didn't actually win $52 in each of those hours. No, I didn't, but I told you that in the first 6 hours, the average was 52. Just like if your average exam score was a 90, let's say out of 4 exams, your average was 90, none of your exam scores have to be 90. You could have gotten a 91, a 92, an 89, and an 88. That averages out to a 90. And really, if you add those up, it's the same thing as adding up 90 times 90 4 times, basically. So having an average of 52 for the first 6 hours means that you could just say, okay, I got 52 the first hour, 52 the second, and so on and so forth. Plus some other number I'll leave blank for the moment. Okay. Well, if that's 52, well, the shorthand way to write that is 6 times 52. I hope you agree with me. Plus some other number I have no idea yet, out of 18 hours altogether. Wait a second. How many hours do I have left? I had 6 spent here. How many hours do I have left? Okay, you should probably say 12. So it's 6 there, plus 12 more hours at some average per hour over 18. Then let's talk about this formula. Let's see, I have these last 12 hours. Each hour I want to average something. In fact, let me hop back to the problem to find out. Let's see. 6 hours, your average winnings are $52 an hour. What must your average be for the remaining time? So that's what we don't know. So let me write that in. We don't know. Sorry that it blinks. We don't know the remaining average. Okay. So I'll just let that equal let number equal that. Okay, so that way when we get back to my problem, we'll see that. But I do know that after everything's said and done, I want the total average to be $75 per hour. So I want this total average right here to equal $75 per hour. Could you solve this? I mean, really, how many unknowns are there here? Just that one. So at this point, multiply both sides by 18. I haven't actually done it. Oh, 75, 1350. So we go over here. 1350 is equal to 312. Oops, 312 plus 12 times number. So let me go back over here. 1350 minus 312 gives me 1038. So 12 times the number is equal to, what did I say? 1038. And finally, divide both sides by 12. So 1038 over 12. And I get 86.5. Or 86.50 actually, since we're talking money. So this tells me that the last 12 hours, each hour I have to have average winnings of $86.50 per hour to then get a total average winning of $75 per hour for the entire trip. This can be written directly into the baseball problem, the baseball averages. It's the same setup.